Okay, so I just read about this library called tacopy that optimizes tail recursion in Python. It converts recursive calls into iterative loops.
Wait, really? So it helps avoid those pesky Stack Overflow errors from deep recursion. That's a game changer.
Absolutely, it's fascinating because it can handle deep recursion without hitting Python's recursion limit. That's huge.
And the performance gains are significant too, right? I think I saw something like 1.41 times faster on average.
Exactly, some cases even showed up to 2.88 times faster. I never thought optimization could be so effective.
But how does it actually work? Is it just magic or is there some deep tech behind it?
It's using abstract syntax tree transformations. It rewrites the tail recursive functions into iterative loops.
That makes sense. So it keeps the function's metadata intact too. That's a big plus for maintaining code quality.
Right, it even ensures functions are properly tail recursive before transformation, which adds a layer of validation.
I wonder if there are any limitations to this. Like, can you use it with any function?
Good question, it can only optimize module-level functions, so nested functions are a no-go.
Oh, and that means async functions wouldn't work either. That's kind of a downside, isn't it?
Yeah, it is, but think about it, it's designed for performance and async functions can complicate things.
Fair point. Still, it's a bit disappointing if you work with a lot of asynchronous code.
True, and you also need to ensure the function's source code is accessible, which could be tricky in some cases.
So practical use might be limited to specific scenarios, but the performance is really enticing.
Definitely, and the ability to run benchmarks on your own is a cool feature. You can really test it out.
Speaking of performance, those benchmarks are pretty impressive. Like, the GCD function showed significant speed improvements.
Exactly, and it's not just one function, several showed consistent improvements, which is impressive.
I wonder how that translates to real-world applications. Would it really make a difference in everyday coding?
For anyone pushing recursion limits, it could mean the difference between a crash and a smooth execution.
I guess so, but what if a developer isn't familiar with tail recursion? They might misuse it, right?
Good point, if they don't understand the requirements, they might end up with a tail recursion error.
That would be frustrating. So, proper education around tail recursion is still crucial, huh?
Absolutely, it's not just about using a tool, it's about understanding the underlying concepts too.
I like how it preserves docstrings and type hints. That makes it easier to maintain code readability.
Totally, keeping the metadata intact ensures that documentation stays reliable for future developers.
And the lack of runtime overhead is impressive too. Optimization happens only at decoration time, right?
Yes, this means you get the performance benefits without slowing down the function during execution.
I'm curious, could this approach be adapted for other programming languages?
It's possible some languages already have built-in tail call optimization, but adapting it could be complex.
I wonder how it would perform in languages that don't handle recursion as well as Python.
That could be a fascinating exploration. There's definitely room for research into cross-language optimization.
And what about the community? Is it actively contributing to tacopy?
Yes, contributions are welcome, and the project encourages engagement from developers.
That's great. Community-driven projects often lead to faster improvements and innovations.
For sure, and with the license being open source, it invites wider use and adaptation.
I can already think of situations where I'd want to use this. It definitely expands what's possible in Python.
Absolutely, just imagine the projects we could enhance with tail call optimization.
It's all about making our code more efficient. I love how tacopy opens that door.
Right, it's all about pushing those boundaries in programming, exciting times ahead.
So if you had to sum it up, tacopy is like giving Python a performance boost while keeping it user-friendly.
Exactly, it's about making powerful techniques accessible to everyday programmers.
I'm definitely eager to try it out. Let's see if it lives up to the hype.
For sure, and it'll be interesting to track how it evolves in the Python community.
Definitely. This technology might just change how we approach recursion in Python.
And that's an exciting prospect. I can't wait to see where it leads us next.